This problem is from section 3.4. It's problem number 21. And we are given the function f of x equals x times the square root of x plus 3. We want to find what intervals is the graph concave up, concave down, any inflection points. So we know that we need to take the second derivative. So I start looking at this function to decide what I need to do to take the derivative. So I'm going to rewrite it like this, but at the same time I'm looking at this function, I'm going to think about the domain of this function. I know that what's underneath the square root has to be greater than or equal to 0, so that tells me that x has to be greater than or equal to -3. So I'm just looking at the interval -3 to infinity. So no matter what, when I work on when I get my critical values or my possible points of inflection, I guess, they have to be in that interval because the graph doesn't exist when x is less than -3. So when I take the first derivative, I'm going to use the product rule. So this will be, if I'm thinking about here, I'm going to have the first times the derivative of the second. And then if I multiply by the inside of that, x plus 3, that's just 1. Plus the second times the derivative of the first. The derivative of the first is just 1. So I'm going to have x plus 3 to the 1/2. And I want to simplify this a bit. So I'm going to have x over 2 times x plus 3 to the 1/2 plus x plus 3 to the 1/2. And then I want to multiply that by 2 times x plus 3 to the 1/2 over 2 times x plus 3 to the 1/2. I want that thing that's going to get me the same denominator. So I'm going to have x plus 2 times x plus 3 to the first power in the numerator, all over my denominator. That's the first derivative of x, and if I clean that up, that's a 2x plus 6, so I'll end up with 3x plus 6 over 2 times x plus 3 to the 1/2. I know that I can factor out a 3 in the numerator, so if I do that, because I can think of this derivative now as 3/2 times a function that has x's in it. X plus 2 over x plus 3 to the 1/2 power. Now I take my second derivative, and I have my 3/2 out here, and I'm going to use the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom. So I'll bring the 1/2 power down, subtract 1 from the power, multiply by the derivative of the inside, all over the bottom squared. So that's, here we go. We have 3/2 times, and then if I clean this up, I have x plus 3 to the 1/2 power minus, and here I'm going to have a fraction, x plus 2 over 2 times x plus 3 to the 1/2 power, all over x plus 3. And remember, I want to multiply by the one thing that's going to get me this denominator, 2 times x plus 3 to the 1/2, which is going to be 2 times x plus 3 to the 1/2 in the top and the bottom. So I have 3/2. And in the numerator, that's going to be 2 times the quantity x plus 3 to the first power minus x plus 2. And I can bring that denominator down with the other denominator. going to bring this 2 out here, so I have 3/4, because that's just a constant. And my numerator is going to be 2x plus 6 minus x minus 2 all over x plus 3 to the 3/2. And so I end up with x plus 4 over x plus 3 to the 3/2 power. So remember, to find my possible points of inflection, I'm going to set my numerator equal to 0, my denominator equal to 0, and here I'm going to get -3, here I'm going to get a -4. So notice that when we get -4, this is not in the interval from -3 to infinity. It's not in our domain. So that's not going to work. So the only critical value we have, or possible point of inflection, I should say, is -3. But remember, our domain is -3 to infinity. So in this function, we only care what the derivative is to the right of -3. So if we put 0 in for x here and here, well, the denominator of our second derivative is always going to be positive because we're taking a square root, and that's why we made the domain bigger than -3. So we really only care what's going to happen in the numerator, x plus 4. So if I stuck in a 0, that would be positive, divided by a positive, times 3/4 is positive. So what that tells me is that f of x is concave up for the entire interval from -3 to infinity. Okay, hope that makes sense. It's a lot of algebra going on, and so it's easy to make a mistake on this one.